The following content has been provided by RWTH Aachen University.
All right, I think we're ready to roll. Good morning, everybody. Happy New Year to you all. Thanks for showing up. We'll have a fresh start into 2021, continuing Designing Interactive Systems 1 today. As usual, we have set your cameras to be off due to the privacy regulations. I encourage you to turn on your video. As you know, all that does is that we're going to see you, so I'm not talking to a black wall of little black squares. And you guys also get to see each other if you open your gallery view, so you can see your fellow students and sort of kind of learn who you might want to talk to if you ever meet them in real life. This is not going to be the recording, as you know, so no problem. You won't be your video won't be recorded. Please keep your Zoom client updated. I'm sure that's something everybody's been telling you when you do video lectures, so that we can make sure all the interactive features work. Questions, again, feel free to raise your little blue hand if you have a question and bring it up to the forum. If you rather want to type something in the chat, that's fine too. Oliver will be monitoring this. I won't be seeing the chat because I'm all distracted sort of giving the lecture, but he'll point out anything to me that we might want to bring up in the larger round of everybody. Okay, with that out of the way, let's jump right in. We started last time to look at the DIA cycle. And you might remember this was a model that we proposed for, for what really? Let's see here. Does anybody have a quick answer? Roughly what the DIA cycle is about? What does that stand for, the DIA?
Good morning. If I'm not mistaken, it was Design, Implement, and Analysis cycle.
Mm-hmm. Design, Implement, Analyze, exactly. Yeah. So anything else you might remember about this?
Well, we go step by step. If it's like a cycle, it's the last step is linked to the first one. So we first need to design our prototype. So create a basic idea what will be created then. Then we go to implementation phase where we produce our result. And then in analysis phase, we compare whether some metrics or some things were reached.
Mm-hmm. Exactly. And so that is basically your iterative cycle that you go through, the iterative user-centered design process, right? As you go through each of these steps, your prototype becomes more and more concrete, more precise. So you try to fix the big bugs first and then the small ones later, right? Related to this was the double diamond model that you can also find in Norman's book in a little bit of more detail. What was that about, the double diamond model? It's also a very visual name for it. So I think from the name, you can almost directly kind of get reminded on what it is about. Yeah, Tejaswini, go ahead.
Yeah, so the double diamond model, we had two phases of divergence and convergence, where in the first phase, you want to discover the different problems and then finding the right one. And then you converge to the right one. And then in the finding the second diamond is to find the right solution, where you discover different solutions and converge to the correct one.
Exactly. Yeah, and this is really also a good reminder of one of the things that really took me a long time to learn and understand, but that really changed my picture of what we do as interaction designers quite drastically, which is you're not so much looking for solutions, you're really looking for the right problem, right? You're really looking for the right problem to solve. Oftentimes, if you just go into it with an engineering mindset, somebody says, solve this, and you go ahead and you solve it with all your technical expertise, but you're actually not really addressing the real problem, you're just fixing symptoms. And so the designer's mindset is to keep asking, are we actually already looking at the root problem here? This root causality issue is a big one, and that really changed my thinking of what I do quite a bit when I learned about this. Okay, and then we had, you know, it's 3 a.m. in the morning. I break into your house, I shake you awake, and I ask you, what are the first 3 questions that you ask when when you're hired as a consultant for a new user interface design project? And you immediately answer, Fabian, you immediately answer.
Can you hear me?
Yep.
Actually, I'm not 100% sure, but I guess you should know who the users are who are going to use it.
Who's the user? Right, that's already 33% correct.
And you should also ask what the user wants to do, or what is the problem that we are trying to solve.
Right, what's the task?
Yeah, what's the task? Yeah. And what makes more sense? Maybe I'm most concerned about constraints I have. So what are my limits? What I'm allowed to do? But that's not the third question. I'm very sure.
No, that's not. And that's the perfect example of. I keep hearing this from people who have an engineering education. They're like, okay, but I need to know the technical constraints, right? You know, I love telling the story where we once gave a completely free design exercise to a group of students from architecture and computer science. We said, you know, invent an object that somehow makes life as a student at RWTH better. Could be a web service, could be a gadget, could be anything, right? We didn't care. And the architect students were like all over the place. And then the computer science student raised his hand and said, how many gigabytes of RAM can it have? That's a typical technical thinking. And you need to think about this once you get into, you know, the reality of can we build this system and how much is it going to cost, and et cetera, et cetera. But before that, you actually want to push these things back a little. A good way to think about what your interface is supposed to do is actually to imagine it as a little bit of a magical device. To say, in the ideal world, if I wanted to turn on, you know, my ceiling lamp, I would do this, you know, hey, ceiling lamp, turn on, or point to it and say brighter or something, right? Or give me the right setting for reading, something like this. I would, that's how you imagine the interaction that you want to go with. And then you put on all the technical constraints that tell you, oh, but, you know, you can't do voice control because it's a multi-user setting, blah, 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 blah. All these other things come into play. But thinking of your interaction as a magical thing is a good starting point. Anyway, so constraints is not it, but it's very indicative that you mentioned the first 2, because for the first 10 years of me giving this class, those were the only 2 questions I was asking. And then as computing permeated everyday life, and we have interactive gadgets in our pockets as we're walking around, we have them on our wrist, we have them, you know, in smart cars, etc. The third question came up, and actually I added it to this list. Anybody remember what the third one is? Yeah, Sarah, go ahead.
Yeah, the third question was about the context. So in which situation or environment we're using the product.
Yeah, exactly. So the context, right? That's the user, task, and context. Those are the first questions that you should be asking. We briefly talked about personas as well. So do you recall what a persona is? What does it describe? Yeah, we got a couple people here. Jonas, go ahead.
Hi, can you hear me?
Yep.
Okay, so a persona is a made-up person, so it doesn't exist, so he or she doesn't exist in real life, but it's more like a concept, so you have a constraint of a group of people, so it may be a representative of a group of people, for example, teenagers, and then you think about, okay, what do most teenagers have? And then you summarize it into one person.
Right. So it's not a real person, but it's designed to be a real person, right? And it's important to understand that it's pretty concrete in its specification, pretty precise, right? It has a name, that person has a real age, a gender, it has interest, it has hobbies, it has dreams of what they want to do in their job, and so on, to avoid having this super elastic, always fitting perfect user who just magically adapts to every situation. So I always like, as an example, this you have, let's say you say, oh, our persona is Bob, and he's 32 years old, and he's a single parent, and then you're designing, let's say, an app to do shopping, and so all of a sudden you realize, so maybe I need to think about that, while he's using this app and pushing this cart through the supermarket, if it's in the supermarket shopping app, he also has to take care of his kid, right? That's running around and distracting him, and so he won't be able to 100% focus on his task. So it helps you really to become more empathic with your users, because you're imagining real people with real world struggles. All right, brainstorming. We looked at that as a first design technique, right? Give me a couple of rules for brainstorming. If you do initiate a brainstorming session, what are a couple of the ground rules you would be putting in place? Yeah, Marta, go ahead.
Yeah, I think, for example, we should not be criticized about each other idea in brainstorming, and we should think about quantity, not the quality of ideas. Mm-hmm. And also, it shouldn't take more than like 10 minutes or so. And right. We should also think about habits in brainstorming, and then try to connect it to gadgets that's used for that habits. And yeah.
Mm-hmm. Okay, so definitely quantity over quality, definitely no criticizing, which is super hard for Germans, right? You can't criticize, you can't do the number one thing that defines our nation. But there's also this leapfrogging idea, right? So as you put brainstorming ideas out, ideally everybody can see them. That's like the classic mode of brainstorming, right? Everybody is yelling ideas. One person is at a whiteboard and just writes them all down. And as you see them there, you get reminded of something else. So you leapfrog on each other's ideas. There's other modes of doing it where everybody just, for themselves collects ideas and then you share them. Different ways to go through that. And once you've got your ideas, on a whiteboard or on a bunch of Post-it notes that everybody wrote individually, we looked at a good way to structure them. Do you remember what that was? Yeah, Jasper, go ahead.
Yeah, you could use a concept map for that. Mm-hmm. So just aligning them and making topics and subtopics and making connections out of them.
Right. So concept maps are basically, computer science speak. In computer science speak, they are basically, trees that start from a root node in the middle and then branch out to the sides. But the idea is that you lay out your information visually so that you can actually, remember it more easily and get an overview more quickly. So one concept map won't be looking like the next concept map, whereas bullet point lists always look like bullet point lists. All right, and then finally, we took a look at storyboards. This was our very first example of how to capture an interaction idea. What are some tricks for doing storyboards? If you tell somebody, draw a storyboard of this interaction, what would you tell them to do? Yeah, Julia, go ahead.
One of the tricks we could use was like drawing kind of like people, like for example, to show a story that we wanted to draw there. We weren't supposed to draw that Strichmännchen. I don't know how it's in English. Mm-hmm. But yeah, you showed us some tricks how we could actually somehow enhance it and make some more natural people like that.
Right. So we talked about how we move beyond Stickman to Starman or Star Trek Man or those kinds of a little bit more expressive figure sketches, right? And it's really it's a communication skill. It's not an artistic, you know, this is not an art class. Fabian, go ahead.
Yeah, I had a little bit of issues by doing storyboards, so I looked it up, and it was more. It was like keep the picture alive and focus on the relevant aspects and the relevant parts of the picture. So the action you want to highlight is what should be in the center of the picture, or what should be focused very much. And the people in the pictures should look alive. So if you draw a stick man, it's like completely away from human anatomy, while Starman has like a body and it is filled. So it looks more alive and more living, so you can more relate and understand the picture, and it looks prettier even though the painting might be worse.
Absolutely, yeah, that's right. As soon as you give it a 2D, you know, at least area of body, not just, you know, a couple lines, it already becomes a little more related, you know, relatable, and you can express some, you know, basic motions with it. We talked about how to sketch hands and stuff like this. Also, I think what you said about putting the action front and center is super important, and there's a great trick about this by drawing something out with a bit of pencil or something, and then going in with a Sharpie or an edding marker, and really highlighting the key lines, the key outlines of your object of interest. It makes it pop, and it automatically looks much more, you know, it communicates much more, and it looks better too. And then finally, we had this idea of, you know, writing a couple words beneath each frame of your storyboard so that you briefly explain what's going on, although that should just be some commentary that goes with it, right? Okay, good. So that was a quick review. So today we're going to continue this topic of very simple prototyping, paper prototypes. In a way, your storyboard that you draw, you could already imagine as your very first prototype, right? Because you had an initial, you have maybe done an analysis, you know, finding a user problem. You've sat down and come up with, brainstormed a couple ideas for what you want to do. Now you draw a storyboard to put your idea into a first, what you could call prototype, right? And then you go back to users and ask them, did I get this problem right? Does that story relate to you? Is that something that you would like to experience from the system? So paper prototypes are usually your very first prototypes. Why do you do them with paper? First of all, it's actually quite quick when you just sketch out something with pencil and you know, a couple Sharpies, then you can actually be very quick. And if you train that just a little bit, you'll be amazed how quick you can put ideas down. It's also very cheap, not because, you know, paper is cheap, but because you don't spend all the time investing in running software, launching an app, getting sucked into your computer, you know, starting to check your mail while you're doing your thing. It's really just you and, you know, this blank sheet of paper, so you can really focus on it. And it's cheap in the sense of the effort that goes into it. What you do in paper prototypes, in the storyboard, we really kind of zoomed out, right? We showed the whole setting, we showed the environment, we showed the user approaching maybe a device or encountering somebody else and then using the device together or alone, whatever. And a paper prototype tends to focus in on the interface. So it's a collection of hand-drawn rough screenshots of the UI or of central dialogues from the UI. For example, if you were to do a car interface, you wouldn't sketch the whole UI of the car because it's super complex with lots of levers and displays, but you would maybe just say, I'm just going to look at, you know, the speedometer display, the central display between speedometer and, you know, and RPM meter or something. This is the toughest one. Don't use your computer. What I mean with this is, don't think that, you know, Adobe Illustrator is a good sketching app. It's not, right? Illustrator is for precise drawings. You can, of course, use a, you know, like a tablet and you know, like a digital pencil, like Apple Pencil on an iPad works great. There are great sketching apps, but it's surprising how hard it is to do an app that really doesn't get in the way. So usually in 90% of the cases, you are better off just taking a piece of paper and getting a pencil and drawing, because there's, that pencil is not out of battery. You don't get menus in the way. You don't need to go through menus to switch the thickness or color of your pencil. So first of all, it's important, again, because of the immediacy and how easy and quick it is. Secondly, it's actually important that it is hand-drawn. Why? Because if you do this hand-drawn sketch that has not a lot of detail and no straight lines, it's immediately clear that you're not trying to be precise. So you and your user who will look at that sketch later will focus on the most important high-level questions and not on the, oh, this button should maybe be round instead of oval, We don't care about this stuff at this point. We care about, should this be a collection of menu items, or should this be a bunch of buttons over here, or how should the interface look in very general terms. So you're focusing on high-level UI design because you're sketching. So, the crudeness of the paper prototype is actually an advantage. And this is hard to get if you're a computer scientist, you like your lines straight, right? And you're very tempted to go in and use the sketching app, and then it automatically makes your circle into a perfect circle. That's not good, right? Turn that feature off if you can. If you need to draw on an iPad, you want a hand-drawn, rough-looking sketch. There are some issues with paper prototypes, of course. You can draw a paper prototype as a simple sequence, boom, 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 and then you can write some commentary under it, which explains why each interface option appears, but it's not very alive, right? If I just see it as a sequence of screenshots, I need somebody to explain it to me. I need somebody to explain why I moved from screen 1 to screen 2. So ideally, you've got a paper prototype, and then you show it to the user in this version, and you say, okay, now if I tap on this, then this other screen appears, right? So you go to like the screen number 2. So you need to kind of drive a paper prototype because it doesn't have any intelligence. It doesn't have any automatic movement in it. It can't react, right? The second thing is, of course, this is easy if you just have to do a few screens. You quickly sketch them out. Maybe you sketch it once and then you photocopy the basic template and you use that 5 times, and then you add things to each subscreen. But with lots of screens, it's a lot of work. And if you change something around, then you may have to change that on several screens. So it can get a bit out of hand. It's still super great, especially for like today's app design, because apps are small things, right? They're not very complex. They're not supposed to be complex. But if you're designing, a very complex application, paper prototypes will run out of steam after a while because it just becomes too much work to keep them updated. But there are ways to fix that. As I said, your storyboard could be considered your first paper prototype, right? It's your first paper prototype that's still not zoomed in on the UI, but sort of more like zoomed out, looking at the context, maybe then showing one screen in your storyboard that is zoomed in on the UI. But you typically show the user's face, the user's hands, whatever, in there. So in that way, storyboards are sort of a very early version of a paper prototype. Apart from these storyboards that zoom out and show the context as well as the interface in detail, we can distinguish paper prototypes in 2 kinds. The first kind is still like a storyboard, but it's zoomed in on the UI. So basically just a couple frames that you put next to each other that each show a sketched snapshot of the UI all on one page, right? And you label each frame, you label why you move from frame A to frame B, you explain why the transition is there. And then you can basically take this and explain to the user, if you talk them through the paper prototype, look, this is what happens in a typical sequence. But of course, it's only one sequence, right? So you cannot say, oh, if the user first clicks this, then this happens, or if the user clicks that, then that happens. That would give you a branching prototype. You don't want to go there. So this is simply just to talk people through a single possible path of interaction, which is, of course, a bit of a limitation, right? It's basically what we call a scenario, right? One scenario you play out concretely, and that's sort of cast in stone in your paper prototype. And as I said, it zooms in on the UI, it shows only the UI. So each of them could be like a screenshot of the actual interface, right? That's the idea. Maybe sometimes you show the user's hand, like the finger reaching in by, indicating that now the user will tap on this button and that takes us to the next screen, right? That's often the case in such a paper prototype, to relate why the prototype moves from one screen to the next. But that's pretty much it. The other way to do it is, of course, to use a flipbook. A flipbook means you sketch each UI snapshot on a separate page, and then you've got a collection of pages. You kind of loosely bind them or organize them so that they don't completely, go haywire on you. And then you show the start screen to the user in your session, in your testing session, and you say, what do you want to do? And the user says, oh, I'm going to click this button. And then you go flip, 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 flip. You find the right page that is the response to this button click that you hopefully sketched. And then you put that out and say, this is the next screen you're seeing. What do you want to do now? Right? And then they pick something. And so you basically, you run the prototype. You are basically, the mind behind the prototype. You're running the automatism, the logic of the software, basically, switching from one UI to the next. That lets you, in a way, simulate the user interface for a user. I'm going to show you an example, first of all, of a storyboard-like prototype.
Yeah, there's a question.
Yeah, go ahead, Aparna.
Yeah, so far what we spoke about paper prototype, it looks like most of it is for a UI design or a software design. How does it apply if someone is wanting to build a physical thing? Let's say we are trying to build a robot, and how does the paper prototyping apply over there?
A great question. In fact, we're going to talk about this in a little bit. This is what we call hardware prototyping. So you can very much, like whenever the shape of your interface is not a standard consumer device, like, smartphone or a laptop or tablet or something like this, or a TV, then you want to build a hardware prototype as well. And that can be made from cardboard or something as simple as that. So, but we're going to talk about hardware prototyping in just a minute. But it's a good point. So here's an example of a storyboard-like prototype that actually already does a bit of cardboard prototyping in there, because you can see the users here. This is a picture that a former PhD student of mine took. This basically shows a cutout of, some kind of smartphone-ish device that has lots of buttons on it. And so now we are seeing here a sequence of screens in the top row that show, okay, so apparently, the user here selects an icon, the Twitter icon, and then, that leads to basically a couple of things being selected here. And there's probably some action below this that is covered currently by the prototype. And then you see some, what kind of actions are available. I guess he selects that tweet, and then, actions on the tweet become available here at the bottom, right? So you can see how this can be used to talk people through an interaction, but it's kind of a sequential thing, right? The user doesn't have much choice. It's really just following along. I'll now show you a flipbook prototype. The second type, right? And this is a prototype done by a couple of DIS1 students, people just like you, who did this, in 2010. And paper prototypes are timeless, so we can still use this example very much. Here's a fun fact. Two of these students, Ignacio Avelino and Kashyap Todi, went on to actually do their PhD in HCI and are now researchers in Finland, in Aalto, I think, and at the University of Maryland in Baltimore. So anyway, what this thing does is it's an application prototype for an iPad. So they made a little kind of screen shape here to show these things inside an iPad screen. And the cardboard box is basically just there to allow users to actually hold the prototype in their hand while testing. The usage scenario is kind of fixed in this one. There's not many options here. So each time the user does something, the experimenter then pulls a paper out of the cardboard and shows the next page. So let me show you what this does. It's you know, some kind of patient data you know, browsing app. So here's the overview of a patient. This could be imagined to be used by a doctor or a nurse. This is the overview screen sketched out. It's got a couple of pieces of information about that person. Just for example, like his illness, diarrhea is listed here. And then you've got some buttons down there that will take you to more detailed views, right? For example, if you click on history, which would be the next screen drawn. See, I'm talking you through the prototype now, right? I'm running it for you. See, there was a little bit of a tap there. That would normally, of course, not be in your paper prototype, but I would do that live, right? If the paper prototype was in front of you, then you would get this kind of like timeline showing you test results of this Max Mustermann of different X-rays and urine samples and blood tests and whatnot. And let's say I now tap X-ray here. Then the next page shows, okay, so that gives me a detailed view of, you know, the data and the scan of the X-ray that I wanted to see. So as you can see, this flipbook prototype lets me talk you through a particular scenario. It could be done also in a way that I actually let the user pick more different things. Let's say the user says, I want to click on CT at the beginning rather than on history. Then I could have a different page in my stack and show that to the user, right? So it gives you the ability to be nonlinear in your interaction. But there's a couple of challenges with these. I mentioned that if the interface gets more and more complex, or if you have lots of screens like this one here, and you now decide that you want to lay them out differently, you need to redraw a lot of screens, right? How can we avoid that? The solution is not the computer, not yet. Hold your horses. We're not going digital yet. We're still staying with pencil and paper, but we're going to do a post-it prototype for that. A post-it prototype actually uses tiny little post-its, right? These sticky notes, and you draw lots of interface components of your UI on these sticky notes. So that makes it more interactive. You can often lay out sort of, you know, a basic frame drawn on a piece of paper, and then you have anything that can change in this UI drawn as a post-it. And oftentimes you've got post-its of different sizes, right? You've got one big one for a window. Inside that window maybe is a menu bar, and then you draw a smaller one for the menu bar. You draw another one for the menus that can drop down, and so on and so on. And so then you can actually stick these notes on and remove them again, and thereby simulate the interaction. And what that does from a computer science point of view is it makes your paper prototype highly modular, right? So you can now exchange one piece. If somebody says, oh, I want to, I want this window to be bigger, you can just change the window background, and then everything else can be still your sticky notes that you already have. So it's much quicker to change by even drawing new notes while user testing. If somebody has a suggestion and you use it, you can just draw that sticky note and put it right in there. If they say, oh, I'm missing a help function here, how about a help function in the top right? You put out a sticky note, you stick it in the top right. What is helpful when you do sticky note, post-it prototype tests, or really also storyboard, anything where you interact with the user, if you can videotape the session to analyze later, is super helpful, because there are a lot of things that happen in the moment that you want to capture, because you need to go back to it later to really understand what the user was trying to express there. So here's an example of a post-it prototype that has radio buttons and checkboxes in there. As you can see here, there's, this is some kind of dialogue where you set a couple of things for maybe for printing or for exporting a table. And I'm going to show you a quick video of this running so that you can see the interaction happening. So here's the prototype, and now we start interacting with it. So for example, here we say, okay, I'm going to, remove this check mark here of the height column, or I can, change the height of the font to be something else, or I can remove the range name and make that a different name. I can move the sticker, like if the user selects something else, I can actually move that little radio button around to be in different places. I can move the check mark around similarly. So the idea is basically, as you can see here, you know, you don't need to continue like erasing and drawing things like crazy. You can actually be almost interactive in your replies to the user's input. This is quite a powerful technique. Let me show you a couple tricks of the trade of what you can do with this if you are if you really want to go with this technique. So here's an example of an expandable dialog box, right? This is an arrow dialog, and if somebody says, "Oh, I'm going to tap on details here. I want to see more details about this arrow dialog," you're like, "No problem." You know, you stick on, you know, maybe you unfold, you know, this little folded node. And show, okay, the details are on the back of this part. So I'm just going to, you know, unfold it, flip it out, and show you the detailed error description, right? And then if these are closed, that again, it would, you know, basically get folded back again. So folding paper is a good trick. Here's another trick. Here's an expandable list, right? Here, the user has a list of files and folders. In this step here, the music folder is still closed. Now, the user may want to like unfold the music folder. So you can do that by just putting another sticky over the existing one that shows the music folder, you know, opened up, right? And now you've lost the stuff that was below it, so you need to stick that beneath with a, you know, sort of wrap up thing here. You can also use this to show, for example, the selection of a drop-down menu, right? That's also possible in a similar way. Here's another example. Here's a file menu, and let's say, by the way, these pictures are taken from a book, Paper Prototyping by Carolyn Snyder. I recommend this if you want to do paper prototyping. It's a great book. Here's an example of how you would gray out some controls. You know, here, for example, save and print are grayed out simply by putting new stickies over the existing ones that are written in a gray font that indicate that this cannot be done. By the way, if you're wondering why on earth we are disabling save and print here, you know, you might say, huh, maybe that's a bad idea, and it maybe turns out that we want to do something else instead and change different things, right? So this is a way to run a prototype in fairly detailed ways with post-its. Another example from DIS1 students here, these guys were asked to design a user interface for a photocopier that allows the user to manipulate how the copies will look, like how the image is cropped on the page, right? And they used, as you can see here, some pieces of paper and cardboard to simulate crop marks. So in their prototype, the idea was that the user could actually move these crop marks around to indicate which area they want cropped, and they simulated this with this prototype. So, you know, be creative with this, right? There's a lot of things you can do with that that will give you an interesting level of flexibility by, you know, just showing things in an interactive, quick and dirty way that you can adapt quickly. Now, once we've seen our paper prototypes, maybe I guess we can take a 3-minute break here. Give you guys a quick bio break. We've been at it for over an hour now. Have we? No, not really, right? Should we? Yeah, we can go a bit, right? We should probably do a little more. We'll do a little bit of software prototyping and then do the break. Sorry about that. Got my times confused. So software prototypes is the next step, right? Obviously, once you figured out the rough user interfaces issues with the paper prototype, you go to software prototypes, and they are medium fidelity, so they're a little more precise, more like the final product, more detailed, more interactive. But make sure that you only create these after you've done some paper prototyping. Really, it's you know, it's very non-typical for, like, untypical for a computer scientist to draw with a pencil on paper. It might feel weird at first, but it's good. Trust me, it really helps. Anyway, once you get to the software prototypes, you usually mock up some, but not all of the aspects of your final user interface, right? You know, for example, with PowerPoint, you can show a couple of PowerPoint slides. Each slide has, you know, again, a screenshot of your UI, and you can let users click through it, right? That's the simplest example of a software prototype. The important thing is here, a software prototype usually has no functionality at first, right? It isn't actually working code. It's really focusing on the UI. It's just simulating what the UI would look like if the code was working. So if the user enters a search term, right, there's nothing that goes off and actually searches a huge database. You just show them one example result, right? You don't spend time coding functionality at this point yet. The advantage, of course, of this is that it gets more engaging for users to try out, and you can also often, send it around as an app or as a website or as whatever, as a Java tool, whatever you fancy, and it gets more engaging for users to try out because they don't need to have the designer around to run it, right? With the software prototype, the big advantage is it can encode the basic navigational knowledge of where to go from which screen, right? The things you needed to do yourself in the paper prototype, where you need to say, okay, which screen am I going to? Okay, page 15. That, of course, is just a hyperlink to go to a different part of your presentation in a keynote or PowerPoint presentation or whatnot, to do that. Now, when I said you don't code in paper prototypes, it's not 100% correct. The most typical software prototype is a horizontal prototype, which means you see the entire user interface, but there's no functionality coded beneath that, right? We just see the UI sort of layer of your code. And everything is simulated, everything is fake, nothing actually works, right? If I hit open, I'm not actually opening a file, I'm just showing a screenshot of a sample file open, right? Something like this. The other way to limit a prototype is vertical. You can say, I'm just going to focus on, let's say, the print function here, and I'm actually going to implement this so that it does a little bit more, that there's some logic behind it. But I'm not going to show the rest of the interface at all, right? So it's just the print function with the UI and a few functions, but these are more, implemented actually in detail. This lets you test by example, right? You say, like, if people get along with this print function, then I guess my model also works for opening and closing files and loading them and so on. The most frequent way of prototyping in software is, however, a combination of both, where you say, I'm going to limit myself severely in the depth, right? I'm not implementing much code at all. And I'm also not showing the entire UI, right? I'm also limiting myself in that way. So I really just stay with this little square up here where I say, I simulate a particular interaction path through my software. So I have no functionality coded, and I also don't show the whole UI. I only show a path, kind of like, your initial storyboard, like prototype that goes through your screen. So let me show you an example of this here. In a shopping app. The idea here is the goal would be to create an app that you can run on your mobile device while you are inside a store, right? And you are walking around something like, Toys R Us, and you are shopping for things, and you discover something that you want on the shelf. And the idea is that this in-store shopping app lets you scan the barcode of this thing, and it automatically gets brought out to, the cash register, or, for you to load into your car or whatever. You don't need to drag it through the shop yourself, right? This could be useful. Anyway, so here's a simulation of this thing. The first thing here is that a user sees this user interface here. What do I need to do? Find the item you want in the catalog or on the shelf, and scan the barcode next to it. So there somebody scans the barcode. And as you can see, the paper prototype here is simulating this. Both the U is a user interface, right? This is an example of a simple animation that we created right here in Keynote that does these things, right? So it shows the user interface, and it shows a little bit of the outside world, right? In this case, we show the barcode that the user scans and the user's hand with the scanner as well. So once I've done this, and notice I'm only clicking through, right? So all the user can do to click through this prototype. It's purely sequential. Once I've scanned this barcode, oh, what happened? I selected a stroller, okay, for children between 1 and 3 years for $98. And I picked it in the color green. All right. It's listed in my little, item list here, and I can see what I need to pay after taxes. But maybe I don't like the color. I want a different color for the stroller. So I switch it to blue. So I tap on blue, and the green logo disappears, and the check mark disappears and moves to blue. Cost, of course, doesn't change. And now I place the order, right? So I click down there and place order. What happens now is that when I hit that, a printer, kicks on this little device and prints out a little tab for me that I can take with me. And that is basically my, my invoice, if you want, my coupon that I give to the cash register, showing what I want to order. So don't worry too much about whether this is a perfectly useful app. But the point is, what I just did is I showed you just a couple animations on a keynote slide, purely sequential, but I was able to relate to you a kind of interaction with an interface, right? So that's an example of a very simple software prototype. It's using a digital medium. It's using, as you can see, clip art and no longer hand drawn, but in actually, computer drawn screens, makes it look much more like the real thing here. And it lets you convey a simple sequence. So that's a software prototype that we could call a screenshot prototype, right? You can use Photoshop for this and just create a bunch of pictures. You can use PowerPoint. What you do is you draw your users, your UI storyboard or your screens. It's a very thin horizontal prototype. We don't expect under screenshot prototypes, there's no functionality stored anywhere. It's easier to change, right? If somebody says, oh, I want to change this aspect of the UI, you just go in and change it throughout your digital prototype. It's easier to change than hand drawings. You can also get a little bit more visually detailed and higher quality, right? You can start maybe using screenshots from the actual UI toolkit that you will be using later. Like if you're building an iPhone app, you could already use UI screenshots from the UI toolkit of the iPhone if you wanted to. But be careful to become too high quality, because the more higher quality it looks, the more polished it looks, the more people will start focusing on the nitty-bitty details rather than talking to you about the big issues in interaction. In some cases, you can use a screenshot prototype and can use artwork that you then actually reuse in your final prototype, right? It can become part of the actual user interface, especially when you're building a non-standard GUI, like a game or something. Then your artwork might actually stick around, right? It could actually be something that you continue to use. And of course, if it's just a PowerPoint presentation, it's super easy to distribute electronically, right? You just send it to somebody, they open it up, they click through it, and maybe even in a live session with you, explaining it to them, but they can share it and work with it directly. If you want to be a little bit more flexible than just a screenshot prototype that goes through everything linearly, like we just did with the shopping app, then you can script the interaction a bit more, right? You can use something like PowerPoint for this, because PowerPoint actually lets you put links into your presentation that jump to other slides. Right, so presentation software lets you put a button on a page, and if you click that, it actually jumps to page, to slide 17 or something. And that could be your non-linear navigation tool that you use. It's basically like a hypertext link in HTML, right? Or you could use different layers in Photoshop to simulate different effects in your user interface in different states of your UI. This lets you sometimes even do simple scene transitions, so you can maybe move from one screen to the next, not abruptly, but with a little bit of animation, like we did with the move in and out of the hand or the scanner there. You can time certain things. For example, you could have a little bit of a waiting dialogue where a little clock spins for like 3 seconds while it simulates that it's looking something up on a remote database. You can have those kinds of effects in there to make it more realistic. So we're getting a little bit more vertical depth here. We're beginning to encode the non-linear sort of graph of interactions into your prototype, but it could still be done in PowerPoint, right? Still no code behind it beyond that. You can use this to give to users as a click-through prototype that they then click on and try out on their own, or you could use it to pitch your own idea, right? You can use it in a meeting where you stand in front of everybody and you show this interface on the big screen, and as you click through it, you explain what it's supposed to do. Advantages: it can look as real as you want, right? You can make it look like a real app, right? If you really went all crazy about it. For non-standard user interfaces, it's a great way to become interactive because you know, you can't really use a good user interface toolkit for that. And you don't need to do any coding, right? You don't need any coding skills, or whoever is doing this thing in your team, the graphic designer maybe, doesn't need to be a JavaScript programmer, right? They can just do this with PowerPoint and a couple of hyperlinks. The disadvantage, of course, is that it still is essentially, even though it can jump around with a couple of buttons, if somebody says, oh, but I want to click on this thing over here, or I want to click the sub item over here, if you didn't implement it, it's not there, right? If you didn't put anything behind it, then it's going to be dead. So oftentimes it still needs a bit of a script or a bit of information to the user saying, the following things are working in this prototype. You can like open a file or close or print a file, but you cannot, for example, save a file. We haven't created that part of the prototype yet. I'm going to show you a couple examples taken from real life. I designed an interactive exhibit years ago that lets you conduct in an orchestra. So you stand in front of a big screen and you pick up a little infrared baton. You pick the piece that you want to play, and then you start waving the baton around and the Vienna Philharmonic actually plays in the way that you conduct. It's a lot of fun. If you ever make your way to Vienna, go to the House of Music, try it out. It's been installed there for like 20 years now, and it's like their #1 tourist attraction. But the way that we did an early prototype of this was actually as layers in Photoshop. And these layers were simulating the highlighting of different menu options or moving to different screens in our prototype. And Photoshop layers are actually a pretty strong thing you can use to do some magic with it. Now, don't be shocked because this looks graphically fairly advanced and fairly fancy. This was because we already had a visual designer on board who did these screens for us. I didn't draw these. In fact, the graphic artwork that he put into this prototype here for us ended up being used in the final tool as well. So I'm going to show you a short video here. Now this is a bit convoluted. We're showing you a video that shows how we step through a Photoshop layer prototype of an interface that is being shown in prototypical form here, right? Okay, so let me roll this for you. So here's, is it already running? Yeah, okay. So we're in Photoshop, right? And we're showing the layers menu here. This is the, and initially this is a state that the user interface would never have because it's showing none of the UI controls at all. But if we enable something, this is sort of, for example, the starting screen, right? It shows the instructions here, and it shows the different music pieces that are available here on the left. And as you can see now, I can highlight these different things, but I normally wouldn't highlight all of these, right? Because that is not useful. So what I would usually do is I would have only one highlighted, and then if the user clicks on something else, I would highlight something else, right? I could basically simulate in that way how the interface would look to the user in each section. And now if you use composited layers, layer comps here, you can actually basically create macros that do that for you. You can see here, there's an initial and highlight Radetzky and so on. And these basically give you a little bit easier control over these layers that almost feel like you're selecting different interface states, because a layer comp basically just combines several changes in layers. You can even step through them back and forth. And now we're actually almost at the level of a click-through prototype here. Okay, so that's an example of this personal orchestra exhibit, the virtual conductor. Problems with screenshots. Well, first of all, there isn't really an interaction going on, right? There is really there isn't much of the dynamic feel of the UI, right? If you only have screenshots, they don't relate quite the same sort of liveliness to you. They also have a danger. If they look too polished, as I said, they limit the feedback that users will give you. Plus, there's this wonderful mistake that management will make. If you show them this screenshot prototype of Personal Orchestra there, they'll say, oh, it looks like your software is all done. I can see it all, right? So you must be finished. You're like, no, 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 we didn't build any of the code yet. This is just a UI prototype. And so that's sometimes difficult to relate to non-technical management that don't understand that a prototype, just because you see the UI, doesn't mean that the interface is there. Why is that the case? It goes right back to what we learned from Don Norman about user interfaces. For users, the UI is the system. The user's mental model of the system is the user interface that they see in front of them. So when they see a user interface that seems to be working, that's a working system to them, right? They don't necessarily understand that there is a huge, 90% of the things that isn't actually there yet. So that needs to be related carefully, especially to your, investors or management. We're, as you guys were pointing out earlier, we're missing the physical aspects of any devices, right? We need to get to that in hardware prototyping a little later. Now, I want to also show you an example of an even more, if you want, flexible nonlinear software prototype. In a way, the Personal Orchestra prototype was already nonlinear, right? I could select any item of these 4 menu items there at will. I could also have selected a help screen that would have switched me to a different view of the system. But to show you another example, this is a bit more recent. I was asked to redesign the website of the computer science department. And so we did this and I created a screenshot prototype. And I created this using Keynote, the Apple presentation tool that is kind of like PowerPoint. And what I did is basically, I created a bunch of screenshots, slides. Each slide was a momentary screenshot of the prototype, but I linked them using these, that feature of Keynote that lets you link to different things. As you can see here, this is showing when you inside Keynote, when you click on an object, you can actually see a little, place a little link here and say link to slide number so-and-so, like slide 32. And that is basically your hyperlink inside your PowerPoint or Keynote presentation. So this means I don't have a predefined sequence of actions now. Kind of like with the Personal Orchestra prototype, I can do what I want in this way and move to whatever I decide to do next. So here's this interface just to show you some examples. And this is now live, right? I'm showing you the actual live Keynote slide that is the prototype. So now I don't need to just step through this, but I can pick what I want. Do I want to learn about, the study program or research or, links to companies or about the department itself? Let's say I'm interested in, research. I click on research, and that takes me to a subgroup of current stuff and people, groups, projects, publications, awards, press, etc. Right? And I can go back. I can go to studies here, and then here's a bunch of things in here like current topics and reasons for studying with us and programs, etc. And let's say I click on study programs here as a submenu of studies, right? So sure enough, this moves me to this, and I can, go back and forth here, look at all of these, and they all have content, right? I can actually use this. I can go back to research and look at that. Here's, information. Oh, sorry, I clicked on economics here. I can see information about that part or about the, the group itself, right? So not all of this is fleshed out in much detail, but also you can see up here, we showed that it's always going to be a couple links to things and a search item. But the search item, for example, doesn't do anything, right? I can't put anything in there. There's nothing happening when I click there. So it's an example of a Keynote prototype. I can pitch the idea of my website. I could pitch it to my colleagues. I used this in our computer science faculty meeting and pitched the idea of what I wanted the website to look like to everybody without having to write a single line of code. And it was actually put together much more quickly than if I were to prototype this all. And it has this rough look, so nobody gets all wound up about why the buttons are yellow or orange, right? They're just it's still a sketched sketchy prototype. We actually used a line style that looked sketched intentionally here to convey that this is a prototype. The next step up from doing something with PowerPoint or a Keynote or something like this is to use a full animation app. Again, this is especially useful if you need to do a non-standard user interface. And usually animation apps use a timeline metaphor, right? So they basically mean that you work with keyframe animation, you define screens along a timeline, and between these you have often very intricate animations going on that you can define. This can be very powerful because animation apps let you also script things. I mean, scripting is not usually, the high end of programming from a computer science point of view, but it's, it's good enough for simple interactivity. And what this often lets you do is to integrate like non-standard input devices or other operating system features. For example, if you do a PowerPoint presentation, there's no easy way to, let's say, integrate a light sensor or something into your prototype, right? If it was supposed to detect ambient light for some basic functionality beyond just clicking through, that's something that you can do with easily with animation apps that let you talk to hardware, let you talk to the OS. Adobe Animate is an example of this that also then lets you, for example, export to HTML5. So you can share your finished prototype as an HTML5 file. Sometimes these animation apps even are good enough to become the final product, right? For example, I've seen when I visited Apple years and years ago, Mac OS X had just been released, and I talked to a graphic designer, and he showed me his animation that he had created in, I think back then it must have been Director or Flash or something like this. And he had created a completely working prototype of this highlighting, magnifying dock effect, right? Where you like have these apps in the dock, and when you click on one, it gets a little bigger, like zoomed in, magnified, like through a looking glass. And when you move across, it shrinks down and the other one gets bigger. And all this was working, and this was all done in like, in a graphic design tool. Pretty amazing. It really looked like the finished thing. But I mean, since they are animation apps, large projects become often hard to manage with these. There used to be a golden era of these tools with Director and Flash, and these days this has become less of a focus because a lot of people then rather go for the web directly. And that's our next example. Of course, tons and tons of user interfaces these days are created on the web, right? A huge part of it, and more apps are being designed as web apps, essentially. So you're working with HTML and JavaScript, and of course, if you were working with, if your final system is supposed to be a web app or a website anyway, then why not use the same web tools to prototype it, right? That makes sense once you move into the software prototyping phase. Then your design can even become the final product, right? It can smoothly go over and you don't need to restart again. Oftentimes when you use prototypes, you don't use them, you don't continue to use them. They've served their purpose once you've done a test with users with them, and at some point you just throw them away, right? That often happens. But sometimes with web design in particular, you can continue to use your prototype if you did it with web technologies. There's lots of tools out there. For example, Electron is one that people are very fond of these days. I mean, this almost changes annually, right? But Electron lets you basically package the same code into native apps for Windows and Mac OS. Like, for example, Slack is an Electron app. What's the editor called? Is a text editor that's running under Atom, I think, is an editor that runs as an Electron app. So you're basically just downloading essentially a whole browser into your in the app and run it natively. What's nice about it is that I should maybe mention Cappuccino is a framework to create advanced web apps. That you write a couple lines of code and then you can create undo, redo, table views, drag and drop, lots of modern UI behavior that you would expect on the desktop. And one advantage of these things is, of course, that you're working in a clear text format, right? So sharing HTML code and so on is easy. It's easy to version control, right? All the things that we like about clear text formats. You can look at it in theory, at least, over using any browser over the net. So that's a nice advantage to share and distribute your prototype. But you know, the nature of the web is also that if you really want pixel accurate rendering of something that you're designing, then the web isn't going to be your friend, right? The precise look and feel is not the idea of how the web works. So there is a whole separate class on web technologies that we are not even beginning to scratch the surface of here, that my dear colleague Ulrich Schröder is teaching, and I highly recommend it if you're interested in you know, how you design and create interactive applications with modern web technologies. He also talks quite a bit in his e-learning classes about learning models that are quite similar to what you learned about, you know, memory and retention in people's memory in our class DIS here. But we're going to give you a very quick demo by Oliver here on how you can use HTML5 and JavaScript to quickly prototype a user interaction, right? For example, drag and drop, which is not something that you typically think of when you hear HTML, right? So Ollie will run this little demo here, and you'll see how you can actually essentially use your web browser as the IDE for this, right? And the whole point of this is just to show that with a few lines of code, you can create something that already looks like an app that does something. It still isn't really doing anything, but it's creating the user interface effects that give you a very interactive, very free-form feel, right? Not scripted as much as the screenshot prototypes, but very much I can click on anything I want, any of the objects, and they all move and so on. So I'm going to switch over to Ollie. I'm going to stop my share.
Okay, so what I already prepared for you is here a very simple static HTML page where we have here a list of items in very light orange box with some vegetables inside, so a carrot, a broccoli, and a pumpkin, and we have a shopping bag. And what we want to prototype here is that we can somehow purchase those vegetables by drag and dropping those items to the bag. And just to quickly describe how this is done in HTML, we have yeah, let me show this in the developer console, which is also very small. I can also make this bigger. I hope you can see everything. We have here two labels in the top, and therefore I just used the HTML tags for a header and normal text, and just added, yeah, for the text inside of that. And then I created two divs, which are container elements in HTML, where here the first div is the one which also includes the different images. So you see here I have an HTML tag with img for image, and I just wrote the name of that image as source. The HTML file, as you can see here, again, very small. The images are in the same folder as the HTML file I'm showing to you at the moment. And yeah, then we have also the other div here with the ID bag, where you just see the image of the shopping bag here. But this is at the moment just the HTML structure. For layouting in HTML, I just copy pasted some stuff from the internet. Here I did some positioning parameters for the divs so that they have a width of 90% of the width of that. Of my browser that I have on the left a 5% margin. I added some code to make everything centered. And I did the same margin code, layouting code for the text labels, which are here for the P tag and the H2 tag, and similar things for the image. But here I also just specified that every image should have a size of 100 pixel by 100 pixel. And now the problem is I have everything here. So Great. Especially for those two divs, they look differently, as you see. I just created some other styles for them. Here for the item list, which is the orange box, I said that this should have a height of 200 pixels. It should have a certain background color and a border. And for the back, I changed the height. I changed a little bit of the margin, layout it, and this is some copy-pasted code again, just to make this back appearing here. Nothing special. If you Google it, you will find this within 3 minutes. So the code to do this. So the problem now is that I cannot do anything with HTML at this form, at least. So you see, I can already drag in caret here. I hope you see this. And I also have this very transparent version of the item I'm dragging. But when I release the mouse button, this shadow, this transparent version jumps back. So for this, we have now to touch a little bit of JavaScript and use some features of HTML5. So the first thing we have to do is we have to say that those items are draggable. So here on the left, you can see my HTML code you have seen in the developer console some minutes before. Here I will edit the website, and therefore we just have to add some text to the image text here. For that, I will now use multi-cursor to not type everything 3 times. I hope this is not too confusing, but it's the same text in all of those 3 lines. So first of all, we say we have to make those elements draggable. And therefore, HTML has a property which is draggable, and we simply can set this to true. And another thing, so now HTML knows, okay, I want to drag those elements, but what we can also do is we can specify what should happen when we start dragging. And therefore, we can use write here another property, which is on drag start. And for that, we can specify a JavaScript function I will show you in a second. And in our case, this function is called drag, simply drag. And it's got parameter, which is event. I think here, just to make it a bit more visible, I'll just decrease the size again a little bit. I hope it's readable. Maybe a thumb. Yeah, okay. And this drag function, this is here again in a little script environment. Yeah, unfortunately in the middle, I wanted to put it up. I forgot to save this. And what happens here is very, very basic. It's of course Java code, but I can promise you I copied it from the HTML docs. So this code is not even written by me by hand. It's just copied from the docs you find online very, very quickly. And the thing, what I'm doing here is just for this event, I just save the ID of the object I'm moving. So if I'm moving the carrot has an ID, which is carrot, and I'm just saving it for the event, such that I have this for later tasks. And that's it at the moment. So that's the information we need for dragging. And then the next thing we have to do is we have to allow other HTML objects to drop those items inside of that. In our case, this is once the item list here in the top and once the back. So when we drag with the broccoli on the back, we want the back to allow this, And therefore, again, HTML makes it very easy for us. Therefore, we just, I write the code here for the back. And therefore, we have, first of all, to allow the dragging operation. For that, we can specify what should happen when we drag over that with a property drag over, and again specify a JavaScript function for that. And this is in our case, allow the drop. And again, we have the parameter event for that. And what this does is also very, very easy. We just call one predefined function, which is prevent default. This is just the simple code to make this, to avoid the standard behavior, which is not letting the drop happen. And with that, we can drop things inside of the bag. And we want to specify what should happen when we do the drop. And this is done by specifying the property on drop. And therefore, we again have to specify again copied function from the internet, which is only drop. And again, we have the parameter pass. And what this does, again, here in our JavaScript section, what this does, it is just asking where we drop it. So if we are dropping it in the bag or in the item list, so here or here, then we again call this function to avoid the standard behavior, which is in this case opening the drag thing as a link, which is not possible here, but nevertheless we need to do this. We get the data we have saved when dragging, and save it here in a variable, and then just add the which was the ID of the object we are dragging, and just add this dragged object to the object we are hovering. Again, at the first, when you see this the first time, it is still maybe a bit confusing, but it's very basic code. If you just spend 3 very calm minutes with that, it's pretty easy to understand. And when we now save this and refresh our browser, you can see if I take the caret and release it here, it's not working, unfortunately. What did I do wrong? I did not refresh properly, sorry. I can simply move the caret there and it stays in the bag. And it's the same for the broccoli and the same for the pumpkin. But well, now if I accidentally just move the pumpkin to the bag, I also want to put it back. And there it's again very easy. It's not possible at the moment, but it will be very soon. We can take the properties we have set for the bag, apply the same for the item list, and save, go to the browser, refresh properly. Well, maybe I do it. Yeah, okay. And as you can see, I can still drag the items into the bag and also place the items back. So this was, here you see everything is around 80 lines of code, and it's very easy. It's very basic. Most of it is already given in the documentation. So this did not require deep thinking of me and a deep preparation. It was a thing which is doable within very few moments, minutes, and I think already with interaction like this, you can do a very, very, very good beginning prototype.
Thanks for demonstrating. So web technology is a huge area. Like I said, whole other class that we don't want to dive into more, but we just want to show that the opportunity is certainly there if you are, especially if you're building a web tool of some sort or a website of some sort, then of course, why not prototype this also using web technologies and reuse your prototype. But the web prototype can be good even for other things. Even if in the end you want to write a native app, you could use web prototyping, especially if you're familiar with the languages and the tools. It'll be a quick start for you. But it is a different style of working from, as you have seen now, I think, from, for example, creating a paper prototype where you're very visual, very spatial, very non-technical. Here we're moving into the coding realm much more. So everything has got its place, right? Each of these things has its own uses. We'll share this simple HTML5 prototype, I think, Ollie, right? Via Moodle, we can give access to that as a resource, so people can pick that up and play with it if they'd like to. Now, next up, the web isn't the only rapid development environment that you can use for this. There's a whole bunch of tools out there that let you very quickly design prototypes using rapid development techniques. Visual-Basic.net is an example from the Windows world that's very successful. TickleTK is an old timer that's been around for decades. that also lets you create, Tickle being the scripting language, and TK being the graphical toolkit to go with it for Windows and icons and so on. These are especially good for standard GUIs, right? Because they create the standard look and feel of their environment, right? If you create something with Visual Basic.NET, you get something that looks like an ordinary Visual Basic app, right? It looks like a Windows app, and that can be a big advantage. You don't have to, painstakingly redraw something that looks like a Windows button. You just, create a Windows button. These things often tend to then become the final product, right? So oftentimes you are, at this point, investing so heavily into the software part of the prototyping that you just stick with it and just develop it into the final product. Some of these systems are interpreted instead of compiled, which means that your development cycle is especially fast, right? I mean, the same thing is true, of course, for the web, right? You change a few lines of what you do there, you reload the page in your browser, and you're immediately there. The interpreted languages, of course, give you the advantage of a quick evaluation and print loop kind of interaction to just try things out. You can update things very quickly. You don't have to go through a building process as you do with normal IDEs. But you may run into performance issues, as you know, and this is, again, for another class. Distribution of these things is okay. They're not always cross-platform. Like if you build something on Tickle TK, that runs pretty much under everything under the sun. But if you build something on Visual Basic.NET, you may tie yourself down to just the Windows platform, depending on how good the cross-platform support of each of these tools is. It may also require a specific runtime environment, right? You may need a particular app installed, which usually is free as a player, but maybe your end users need to have something installed to run your prototype, which is something, a little bit of housekeeping that you need to take care of. So far, we've looked at prototyping tools for, more like non-standard UIs, where you are like, games, immersive applications, things that don't use your standard tools and buttons, and we've looked at things that use the standard GUI toolkits, like Visual Basic.NET, for example. Sometimes you also have a very special purpose area. For example, in the area of multimedia processing. So when you talk about processing sound, processing microphone input, creating audio output that is complex and computed, some computational audio. If you are dealing with video input, live camera feed, and you want to react to certain things that you see in your image, or you want to create complex animations, or you want to create an artistic exhibit or something that reacts to users walking through a room detected by a camera and then creating weird projections on the wall. That is an example of multimedia app development. And for that, for example, there is a tool called Max MSP that actually lets you do exactly that. It was originally designed for MIDI applications. Now, MIDI was a standard developed in the 80s to link synthesizers to each other. And what the key change was that you were no longer sending the actual audio wave through it, like your music going through your cable through to your headphone or to your amp, but it was actually sending the logical semantics of the music. So it was sending information in digital format that said, play a C4, which is a certain frequency on the piano keyboard, play that with the sound of, let's say, an organ, and play it this loud for this many seconds. So by sending this message information across the line, MIDI revolutionized how people were creating digital music, and it's been around to this very day. And Max originally allowed you to do processing of this MIDI information. It would get information maybe from a pressure sensor that somebody was squeezing, and then you could basically react to that by creating a sound output that was changing accordingly. It was soon extended to handle full audio processing, so waveform audio processing, not just this control sort of semantic MIDI format. It then was extended to handle the display of 2D graphics, image processing, and rendering. And it was extended to handle video input and output. So it could analyze video input coming in and look for blobs, for example, in an image, a bit like what you get with OpenCV these days. The unique thing about Max is that you create your software by patching little blocks together. So it's a flow-based programming environment. And flow-based is its own whole beast, but you've certainly seen some sort of this. Here's an example of a running program that has basically a couple of blocks here, like a JIT movie and a Q Metro and a RAID and a read block that do certain things, and they are linked with lines so that events basically flow from one object's bottom into the next object's top entry point here. What this thing, for example, would do is it would get, when you click into this top left box here and enable it, this is just basically a toggle switch, then it would start sending out signals at a regular frequency, which is this metro, which is short for metronome. And whenever this metronome sends out a little blip signal here, or a bang as it's called in MaxMSP, then this movie component here, which is part of the jitter environment, which deals with video processing, would basically grab a frame from the camera that's coming in and would display it and would send it out its output. And then here we have a little bit of a display area that would show that current frame, right? So this is basically a screen grabber here that we're seeing right now. And what you can adjust here is, for example, the frame rate at which things are being grabbed. If you don't want to go with these 33, then you can change this value up here, because if you change this number here, then that number will be loaded into this right top input here of the metro object, and will change the 33 into something else. So it's basically data flowing through patches, which is very close to how you do audio wiring, right? You've sent your audio signal through a distortion amplifier or something like this. So this was what inspired this design, and it has proven itself to be very flexible for all kinds of multimedia design. In the mid-90s, I actually designed an interactive art exhibit about music for the Ars Electronica Center in Linz, Austria, which is a big sort of museum, tech museum, if you want, that was being built at the time. And we used MaxMSP completely for the entire exhibit. It would let you, play blues music and on a virtual xylophone that was in midair that you could bang with two sticks on, and would let you hum a tune, and it would look for the tune in its audio database. So it was a couple of different fun interactions with audio and music that this exhibit featured. And we built it completely using that tool, which is possible, right? It's very helpful for this particular type of applications that needs to process audio, MIDI video, for example, or any interactive sort of music application. Worldbeat was the exhibit that I talked about that we used it for in the end product. And you can distribute it freely because there are players for the major platforms that can run this thing. You need to, after initial trial period, you need to pay for the development environment, but you can distribute patches freely. Anyway, so that's an example of a special purpose prototyping tool. So you wouldn't want to try to do this with any of the other tools I've talked about so far, because it's so geared towards making it easy to process live multimedia data that it really pays off. Beyond that, going back more into sort of the standard world of your graphical desktop user interface or a smartphone user interface, you have what's called user interface builders. These are tools, usually graphical these days, although they often also have a textual component that help you to define the UI of a real software application. They're usually part of your IDE, right? So if you run an IDE to develop under Windows or under Mac OS, for example, then you get an interface builder for free as part of that. The big advantage of this, of course, is that if you design something in this, you can use that directly for your final implementation, right? It's something where you can really reuse your stuff directly. You also get the real look and feel, right? That basically lets you really make things look and feel, and which means interact like the real thing, because it is the real thing, right? You're really building an app. And of course, it also is super easy to build vertical functionality into this, because that's what they're meant to do, right? They are there to design the interface, but they closely tie into the rest of the development environment to prototype something. The disadvantage, of course, is usually you are limited to a particular Windows system, right? If you design something with, for example, Xcode, the Mac OS X development environment, the Mac OS development environment, then you're tied to writing apps for the Mac, for the iPhone, for the iPad, for the Apple TV, and the Apple Watch, right? The Apple ecosystem, basically. Here's an example of this. This is a screenshot from the interface builder app that is part of the Xcode environment under macOS. We will cover this in more detail in DIS2, so don't get too wound up about this now. I just want to show you what's possible. What we're seeing here is on the left hand, you've got your typical file browser that shows you that we're currently editing what's called a main storyboard. Down here, you have the different components that are part of your storyboard. Like you've got your window controller, you've got a view controller here. And what you can see in the middle here is sort of your storyboard developing. So what we're suggesting here is that this app has obviously a main menu, as you can see here at the top. We have that main menu the app is called temperature converter. It has a couple of menu items, and the item has then a window, or the app has a window, and inside that window is content that has boxes with Fahrenheit and Celsius that you can put numbers into, and that can then be converted by clicking that button. And this is not exciting, right? This is what most of these interface design tools can do. What I find exciting is that here you can now click on the convert button. I think you right click on it, and then you can actually drag directly to a piece of code that you want to execute when that button gets pressed. So this is an example of how you connect graphically connect your user interface to the code in your app. So this is how, for the last 20 years, I would say roughly, people have been designing apps for the Mac and then later also for iOS by doing this. And just last year, an even sort of more integrated way came around that we're going to talk more about in DIS2. It's called Swift UI, and lets you basically code, write your user interface in Swift in very simple terms, and creates it directly in a graphical editor, and the graphical editor and the code are fully synced. So you can describe it as code or describe it using a graphical editor. They're both the same thing. But more about that, as I said, in DIS2. Now, there's a couple of problems with software prototypes. Once you move to the software prototyping phase, you are really getting to users to focus on design details, which is okay at that phase. But you have to make sure that you have identified the big issues, right? Using paper prototypes. If you immediately jump in with something that looks almost like the finished product, people are, first of all, going to be afraid to criticize, because it looks like you've done so much work, because obviously the system is almost done, right? That's what it looks like to them. So they are much more hesitant to criticize your design in fundamental ways, to say, for example, oh, we don't need this whole menu system. We need something completely different. We need, a bunch of push buttons down here. The second thing is this, as I said, the management may think it's real, especially with a software prototype. It looks like the software is almost done because the users think that the interface is the system. It has to do with conceptual models, as I explained before. So that is something to be careful about. And from this, we can now move to the question that came up initially. What do you do if your system actually is not a standard software app for a phone or for a tablet or for a laptop or something like this. So you want to also understand whether how the thing is going to physically look. Hardware prototypes are something that you do whenever it's hard to imagine the system, when it's hard for the user to imagine interacting with the system by software alone. There's a wonderful story about this. The Palm Pilot was an early PDA, so it's kind of like the predecessor of the modern smartphone, that were all the rage in the 90s, all up to the mid-2000s. And Palm was the first company that created one of these little, roughly like pocket calculator sized devices that you could scribble on with a little pencil, and it would recognize your handwriting, and it would manage your agendas, your calendar and your contacts and all those and reminders and so on. So it's kind of like, a thing with a couple apps on it, but not a smartphone, not a phone, more kind of like all the other smart apps of a smartphone. And the guy who founded the Palm business, before they decided on any kind of features that would go into this Palm Pilot, or decided on any kind of technological ways to do this, to build this thing, he had his workshop create a bunch of wooden blocks. These were simple wooden blocks of different sizes, and he asked everybody on his team to carry these wooden blocks, different ones, with them for like a week or longer, every day, in their shirt pocket or in their pocket of their pants or in their handbag or whatever it was. And he said, no matter how useful our device is going to be later, what kind of awesome functionality we put on it, if people don't always carry it with them, it's useless. We expect them to always take this thing with them. And so it has to have a shape that makes people do that. And so he had people walk around with these different wooden blocks and just test out whether the actual size and shape was actually going to work for them to be something that they could have with them every day. And that led then in the end to a shape that isn't unlike what you have today with sort of like the slightly bigger smartphones actually. So very flat, so it would easily fit into any pockets, and kind of rectangular shape with slightly rounded edges. So this is what what shows how important it can be to actually have a hardware prototype. In this case, the hardware prototype didn't do anything. It was just a dumb block of wood, but it helped you understand, does the physicality of this device make any sense even? And this then later, to get back to Fabian's comment, gets you into these things of, now we know that the physical size can be no bigger than this, so our engineers need to work with this size for battery, and for the size of the battery, the size of the display, etc., etc. Or if you have something where the physical interaction is actually super important, like you're designing a new 3D mouse, then of course you need hardware prototypes, right? You can do these in wood. You can do them in foam core. Foam core is a fantastic material that is very easy to file down and to round off into shapes. But once you've created a shape, it's very lightweight, and you can handle it quite nicely. It doesn't break immediately. You can also use a bunch of plastics, styrofoam, although styrofoam tends to be messy because it has all these little things flying off it that get statically charged and then stick to you. Of course, a lot of people also build with cardboard, right? That's also something that you've done since first grade in kindergarten. The problem, of course, of hardware prototypes is, since they are a physical thing, it's a high effort to build them, a higher effort than just drawing a few lines on a piece of paper or creating a quick software prototype, and changing them is, of course, also more expensive. But sometimes it's definitely the way to go. So here's a couple examples. When Microsoft developed their new touch mouse, they carved dozens of possible variations in this low density soft foam, which is called Ren board. That is super easy to sculpt and to file down. You have to, the reason was because you cannot actually just compute the perfect shape of a mouse. You kind of have to sculpt it, hold it in your hand, play with it, try it, and try out a bunch of variations. So here's a couple of these examples on that picture. Another example, Pebble was an early smartphone maker that created a smartwatch maker that created a smartwatch that had an e-ink display. So it had a very long battery life because the e-ink display doesn't consume any energy unless it changes. They also used 3D printing to create their prototypes, as you can see here in this picture. By the way, our lab has a fully equipped Fab Lab. And once we can make it back into the lab, hopefully soon, the Fab Lab is a wonderful playground for you guys. It has 3D printers, it's got laser cutters, it's got not just your average home 3D printer that prints with, plastic squirted out of a tube, but it also has high-end printers that can create prints that are so fine that you can create a screw thread that you can actually screw a metal screw into. And we've got devices to create printed circuit boards. We got a full electronics workshop, so you can make your prototypes interactive there. There's a bunch of hand tools out there. So the Fab Lab is a place where you can create hardware prototypes really, really well. And not just physical shape, but also add functionality to them once you advance into this. We got a couple classes that actually use the Fab Lab, and we hope to be able to, maybe in the summer semester, get you guys to experience that again if we get access to it. Here's another example of a prototype. This was made from just a couple pieces of cardboard, but it was a remote, right? They were designing a remote, and they took cardboard, they cut out little shapes from other cardboard things to create the buttons on it, and had a slide-in screen to slot in different screenshots that they had sketched with pencil and paper. And that's a wonderful example of a low fidelity device where nobody will get all hooked up on the exact look and feel of the buttons or the display, but they can try out the functionality. And if somebody doesn't like a button where it is, you just rip it off and stick it somewhere else, right? At the other edge of at the other end of the spectrum is a system that I show you here as an example. Years ago, we ran an early sort of hardware prototyping lab with students, and this is Laszlo, one of our students back then, and we told them to create an interactive instrument and prototype it. And so he created the virtual air guitar simulator, or as they called it, Bangorama. Why was it called Bangorama? Because you actually play this air guitar by headbanging. So what they did in order to actually make this a working prototype is they glued a tiny little, you have to wear a cap, and on that cap is a tiny little switch that goes back and forth when you headbang, and that switch is literally like a cent coin glued onto a piece of wire, and it closes contact whenever you bang your head, and that closed contact then gets fed into this little circuit that's inside the air guitar, and the air guitar is just made from some aluminum foil conductive pads that you can hold your fingers onto, and then you close the circuit when you do that, and you play notes by banging your head. So wonderful example of a very quick prototype that was made in extremely short time, and that was actually functional, right? So this is really showing you that hardware prototyping doesn't just mean creating a dumb piece of plastic or wood or cardboard. You can also infuse it with the soul, with the interactive behavior of what you are imagining. And that is something that's actually been hard to do in the past. Oftentimes what I would see back in like the early 2000s, people would either create a software prototype on a computer that would be all virtual, and it would be very complex and could do all kinds of things. But their hardware prototype would basically just be this block, right? This meaningless piece of cardboard that just showed you what it would feel like, but it wouldn't do anything. But with the technologies that have become available in the last sort of 10, 15 years, with the Arduino microcontroller and all the whole maker movement, making 3D printing and all these things, laser cutting accessible, and putting intelligence into these things using microcontrollers, it's actually become quite feasible to create working prototypes. So let me show you this video. I know you're waiting for this. So here's how the Bangorama virtual air guitar simulator worked in the final demo. As you can see, this was using all the things, pulling all the stops. So I actually used Max MSP to run the logic for this, not on an Arduino. I was wrong about this. It was actually running on the computer that's behind them there on the Mac. That was basically detecting these clicks and then playing the next note accordingly. All right, we're almost done. I only have one more technique to share, and it only has a single slide, but it is one of the most important prototyping techniques because it's kind of surprising what you can do with it. And it's called Wizard of Oz. Fortunately, it has a funky, cool name, so it's easy to memorize. Wizard of Oz, first of all, okay, I have to ask this. Does anybody know the story from the Wizard of Oz? Like, who is the Wizard of Oz and what does he do? Johanna, you're nodding. Can you explain to us, what does the Wizard of Oz in the end, what is he actually doing? Who is he and how does he appear? You need to unmute yourself.
He makes the wishes come true.
Yes, yes. But is the Wizard of Oz? He appears as this giant figure, right, in the movie, and who is he in the end?
It was I don't know English word. Like, he was not like actually a wizard.
Yeah,
it was
right.
Fake wizard.
He was a fake wizard. He was just Rachel. You want to explain that to us?
Yeah, it was just a human sitting in the big machine and like steering the big head and the machine elements.
Exactly. Yeah. So thank you for sharing that piece of pop culture with us. This will not be on the test, but the Wizard of Oz, in this picture here, you see here, the Wizard of Oz is the guy on the right, or on the bottom, I should say, who's sitting in front of his computer. So let me explain how that works. When you do a Wizard of Oz prototype, you have one human wizard who simulates the response of the system. He's the guy sitting at the bottom here in this picture. The guy at the top is the user. And in this example here, we're showing an early example of how IBM used the Wizard of Oz technique, because they wanted to prototype an editor that was controlled by voice recognition. But this is 1984. Voice recognition really sucked back then. It was really bad. So they didn't have the technology to actually easily do a good voice recognition yet, at least not quickly and at a low price. But they wanted to understand, how should a system work if we had really good voice recognition a few years down the line? They wanted to get an early start to thinking about the interactions that this was enable. Like, how do you edit a text with voice recognition? How do you tell the editor to go back 3 words and change that word into something else, right? It's a problem to this very day. So what they did is basically they simulated voice recognition. So the guy at the top is speaking into a microphone, thinking that he is talking to a computer. And he doesn't see the Wizard of Oz at the bottom. They are usually in 2 separate rooms, right? This picture is a little misleading. We would have to imagine the Wizard of Oz to be in a completely different room, invisible to the user. And so the wizard is usually hidden in a separate room. He hears what the user is saying, and he basically then just types that in. And then that appears back on the computer of the user, who thinks, oh my God, the computer has recognized my voice, and he's perfectly done what I've asked him to do, to write or to spell or whatever. So the idea of this, why would you do that? Well, there's a particular technology or functionality that is very complex because it's maybe not available yet, like voice recognition at good quality in 1984. Or maybe it's just available but incredibly complex to program, like voice recognition today, right? And you want to simulate that early on in your prototype to see whether it makes sense as an interaction technique, even if it worked technically, if it was something users actually wanted. So you basically use a person to simulate a really good voice recognition system. The idea is sometimes you can see the Wizard of Oz and the user knows that this is going on. And in most cases, you actually don't tell the user about this, so that you create this illusion of, this is working technology and we're not faking this right now. That's why it's a reference to Wizard of Oz, of course, right? Because of the tiny guy controlling this huge puppet, the Wizard of Oz, that is really just this tiny guy behind the scenes. Another anecdote related to this, we had a thesis here a couple of years ago where somebody needed to do gesture control in front of a big screen. And she wanted to explore the use of gestures in a user interface. But back at the time, this was in 2010, we didn't have really good gesture recognition, at least not, to quickly set up for a user study. So she put 3 cameras in front of the user and let them interact with a big screen, a wall-mounted screen, and 3 cameras around it. And then told the user that these cameras were watching them for real gesture recognition, and told them what gestures they could do and how it would work and all that. In reality, users were waving their hands around and interacting with the screen. In reality, somebody was watching the camera feeds in a different room and was basically just reacting on the big screen as if the system had recognized that corresponding gesture, right? So she could fake the gesture recognition and start studying how people would work with such a system, even though it didn't exist yet, and even though the technology maybe wasn't readily available yet. And that's a huge chance to test interactions with some up and coming amazing technology that is around the corner, and you want to understand now how interaction with it should work or could work. All right, so wrapping up, last slide here. What do you do with a prototype? There's 2 things. You can keep it or throw it away. Lots of prototypes are actually thrown out, especially if their creation was quick and cheap, which is usually the case for the paper prototype, right? What are you going to do with the paper prototype? Prototypes are there to answer questions. This is something to really keep in mind. They have a purpose, and the purpose is to find out whether you are on the right path for your design, right? They don't have a purpose in themselves. Usually, they're just there to answer these design questions. You've developed an idea in your design phase of the DIA cycle. You implement it using a prototype to see whether your idea is good. You test it with people. Sometimes you can also test it without users, just with an expert review. And then you go back to the design stage. And sometimes that means that you improve your prototype in the current shape, like you might fix your paper prototype a couple times. But at some point, the paper prototype has served its purpose. You can put it into a file folder, store it away, maybe keep it around for your later project documentation, but you don't really need it anymore because it has answered the questions that you wanted to answer. Especially if you documented that well and tape the interactions of the users with the prototype, then you've got video examples of this. Sometimes, however, you can continue to use your prototype. For example, if the paper prototype just needs some, if you just discover a big issue with your design, you fix it in your paper prototype, but you're not sure whether the new version is actually ready to go forward, right? If that's what you want to go forward with in your development. So you do another round of paper prototyping with that new idea, right? That's why it's so quick and cheap to change. If you continue to develop that way, then of course, at some point, your paper prototype won't be able to be the final shippable product. You certainly have to switch, but with some software prototyping techniques, you can actually make it all the way into the final product. Like this example of the music exhibit I talked about, where you can play blues and recognize melodies. We initially were designing it with this Maximus P system because it was a quick prototyping tool, but we discovered after a while that actually it's so good and so powerful and can handle the complexity well enough that we just built a complete system with it. So we just continued to improve the prototype and didn't have to switch out the prototyping tool once we had moved into the software prototyping phase with Maximus P. Of course, we'd done other paper prototypes before that, but once we'd moved to software prototyping, we could stick with Maximus P all the way through the project. The problem with that, of course, is that you need to use something that can actually handle, you know, the demands of a production tool, right? It has to be fast enough, it has to be manageable, it has to be maintainable, and robust enough to do that. And not all the software prototyping techniques are of that kind. All right, we're at the 12-hour mark. That's it for today. We actually finished up a little earlier than we thought. So enjoy a little bit of an earlier lunch break for today. And I'll see you again next time. Thanks for dialing in. Bye.
This content was provided by RWTH Aachen University.